Okay, so this is problem 3.3.63, and they're asking you essentially to construct a truth table for this statement right here, and they want you to determine whether or not it is a tautology. And a tautology is something that has all truths in its last column whenever you've done the truth table. Okay, so the first thing is I've gone ahead and built a truth table here, and I want to just talk you through how I built this so we know how it's going to go. Okay, so the first thing is we're dealing with three variables. So we're going to have a column for P, a column for Q, and a column for R. And then this is what I'm trying to build here. And I just noticed that I wrote that backwards. Okay, with the or it doesn't actually matter, but this is Q or P. Alright, so what we're trying to build here is this. So we're going to work within the innermost parentheses first on the left-hand side. So you notice that we have a Q or P. And so that's going to be our next column here, Q or P. It's kind of, can't see that very well now, but that's a Q or P column. And then we've got a not R, and we're trying to conjunct this Q or P with a not R. So I'm going to give myself a not R column. And then I have, so now I have these two built. I have the Q or P and the not R. So then I'm going to do a column where I bring those together using the conjunction. So that's going to be this column right here. And then I'm trying to do the conditional with P, so I need another column for P. So I'm just going to move P over. And, you know, P is written over here, but I'm going to move it over here. And that's because whenever we're doing a conditional, the order of it matters. And that's because a true-false is different than a false-true when we're dealing with a conditional. Okay, so I'm going to put the P here, and then I can combine this column and this column right here into my conditional for the last column. Okay, so the way that I'm going to do this is I'm going to start with 4 truths in the P column and 4 falses in a row. And we want to do this pattern that I'm going to show you so that we can accommodate for every true-false combination between the 3 variables. Okay, so then with Q, if we list Q as true, true, false, false, and keep that pattern, true, true, false, false. And then with R, we're going to oscillate true, false, true, false. And that will take into account every possible true-false combination between the 3 of them. Okay, so this column right here, you can't see it very well. It's Q or P. So we're doing a disjunction between these 2 columns right here. Okay, now the only time the disjunction is false is when both of them are false. And so if we just look down here, we have 2 falses down here. So these 2 are going to be false, and then everything else is going to be true. Okay, and obviously I'm getting that from, if you just look at the disjunction truth table here, and we did these out in your notes. Let's see if I can get that. There we go. So notice that the disjunction is only false when both of them are false, and every other combination it's true. Okay, so that's where I'm getting these true-false values there. Okay, and then the next column is the negation of R, and so I'm just going to flip all of these values. So I got a true here, and I'm going to make it a false, and a false here is going to make it a true, and so I'm just going to continue that pattern all the way down. Okay. All right, now what I'm going to do is I'm going to take these 2 columns right here, this Q or P column and my not R column, and I'm going to combine them using a conjunction. So for instance, here I've got, you know, a true, and I've got a true value and a false value, and I want to combine those in using a conjunction. So a true and a false is going to give me false. And in fact, whenever we're using a conjunction, the only time it's true is when both of them are true. Okay, so if I just go down these and look, here's a true, true, that'll give me a true. Here's a true, true, and then here's a true, true. Okay, and then everything else will be false here. So that's the easiest way to deal with these, is to do the piece that stands out first. Okay, now I'm going to copy again my P column. So I've got true, 4 trues in a row, and then 4 falses. And now I'm doing a conditional between these 2 columns. Now the only time that the conditional is false is when you have a true for the first, for the antecedent, and a false for the consequence, for the second part. Okay, so let's just look. Do we have any true falses here? No, 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 no. Here's a true false. Okay, So my true false here is going to end up being false, but everything else is going to end up being true. So this ends up being not a tautology because of the fact that we have one false value in our final column. A tautology, like I was saying before, is something that is true for all of these values, which means that it's logically valid. And because of this false value right here, this is not a tautology, which also means that if this had come from an argument, like some, sort of a bunch of statements that we then converted into this, like you'll be doing in section 3.6, it would mean that that statement was logically invalid. Okay, but for now, for this section, this is what they're asking you to identify, and this is not a tautology.